I think we can start now. So, first of all, a very warm welcome to everybody who's joining now. My name is Izu. I'm the current head of Innovation Forum at Cambridge. Today, we'll be talking about food tech and science, solutions for a new era. So, I'm going to say a few words about the Innovation Forum. So, the Innovation Forum is a global network of innovators and scientists and medical students, as well as other allies. What we try to do is to try to encourage innovation um, through many events, such as this one. One of our main events is the Innovation Forum Imagine If competition. It's a global accelerator. And basically what it is a competition that allows different small companies to get funding as well as experience. So if you wish to have to have more information on Imagine If, I would really love to invite you to visit our webpage, innovationforum.org/accelerator. For more information about Imagine If competition. So without further ado, Faisal, can you please introduce our first speaker?
Hi, I'd love to introduce you. It's a pleasure to introduce you, Alexander Giles. He is the Chief Commercial Director of Iceni Labs and a Commercial Director of Liberty Produce. Basically, it's a farming technology company growing British produce year-round using fully controlled indoor vertical farming system. Giles' passion is to develop capabilities for new and next generation technologies that provides commercial value and brings benefits to the grower. So this is the first speaker we have. And so should we start with the presentation right now? Or should I just introduce the other speakers?
Yeah, Alex, can you please start your presentation?
Yeah, happy to do so. Well, first of all, thank you very much for that introduction, and thank you very much for the invitation. I'm relieved to go first because it will mean that you'll get 3 experts following me, and hopefully by then you'll have forgotten anything silly that I have said. So I want to be, really clear. I'm an accidental ag-tech individual. I've been involved in the business for probably under 2 years, a year and a half or so. As was mentioned, I'm actually the co-founder of Iceni Labs, and Iceni Labs is a business that works across a whole field of technologies, defense and security, medical, advanced materials. We got into the ag-tech business because my co-founder, Dr. Dylan Banks, was doing some research in the field of vertical farming, and we got to a point in which we decided that a spin-out company would be a sensible approach. So we formed Liberty Produce. We were very fortunate enough to early on win a substantial government innovation grant, which allowed us with a group of partners to begin what we believe is some really exciting research across a number of areas into vertical farming. And then we were able to partner with CHAP, the Crop Health and Protection Agency, to build our first physical facility, which is located up at the James Hutton Institute in Scotland. The fact that it's in Scotland explains that photograph of me with the rather windswept hair, which was taken up there. So those of you familiar with Scotland will realise that's a pretty standard look for everyone up there. But we've been up there now, formally launched since last October. We're delighted with the way things are going up there. We've been at capacity pretty much since that point in the work that we're doing. We're looking at tripling the size of that facility, and this week we were able to sign an MOU with the James Hutton Institute to more closely partner on a number of projects, and I'm happy to talk about a couple of the things that we're doing with them and other partners in this short presentation. So that is a picture of the interior of our future farming hub. As as I mentioned, I need to be clear about this. It's a research and development facility. It is not there. We are not farmers. We are very much see ourselves as suppliers of technology and research, working a lot, as I mentioned, with the James Hutton to work out, the new technologies that are going to make vertical farming, great and a really important element of our food security and dealing with climate change and all these other big issues that we've got going on. One of the things that we've started doing a lot of work on, which we think is very exciting, is within the speed breeding program of varying breeds. And first of all, sorry, to jump back a bit, and I'm sure these slides will be available, that perhaps gives you an idea of the breadth of what we do within, at the moment, what's quite a small facility. I would say at the moment we're probably the most over-engineered vertical farm in the world right now. So, we incorporate all of the different hydroponic systems that are sort of currently majorly used. We are fully touchscreen controlled. Our lighting system, which is our own IP, full spectrum lighting system, and we have a 12 stage nutrition system as well. So incredibly over-engineered for if we were just going to produce as a farm, but a really great facility for those that come to us wanting to do research and to test new ideas. And this is just an example of some of the work that we do. This is work we do with Dr. Susan McCullum at the James Hutton into speed breeding. There are two big commercial customers who are leading this exercise. You'll forgive me, I can't mention them for confidential reasons. But it's been a really exciting process for us, really demonstrating what we think are some of the big advantages of vertical farming, of controlled environment, and what it can do for the future. And to put it into basic terms, what we're able to do is cut that germination time of those blueberries all the way from a 10-week, which is standard, to under 3 weeks is where we are now. That work is now, we hope, to be expanded into some joint partnerships in Kenya and in Singapore as well. So we're very excited to take this type of work, not just on the blueberries, but across a whole bunch of soft fruits into places where that's going to prove to be real value. So again, there's a little picture of the inside there, and has capacity. What I would say is, when I first dabbled, for want of a better term, into vertical farming, I think there was still this sort of belief that it was only good for microgreens, and that this would be what people would do, and that to a certain extent was driven by the economics of it. You could really only turn a profit if you were growing something like microgreens, where you get high price for them. What we think is that vertical farming, particularly in this speed breeding angle, shows huge benefits in biodiversity, and that possibility to grow this far greater range of crops in austere environments. And it brings us to our concept of more of a hybrid approach, a hybrid future, as we say there. We think that vertical farming, it doesn't have to replace conventional glass houses. This idea that has been mooted in some parts, that we would tear down existing infrastructure, of which in a lot of cases people have spent an enormous amount of money on, that we don't think is the future. But if you take elements of vertical farming, whether that's placing units in container farms, in ISO containers as our facility right now, or whether you just put it alongside into some other structure, you can get some great results. And that might be, as we're doing, that you might need vertical farming at the propagation stage, and then move into glass houses and move into open acre. But very much look for a hybrid approach. I'd say that don't follow the herd. If you're on this webinar now, you're thinking about building a vertical farming facility, there are lots of really high value crops, not just in the ones that you might traditionally think of, ones you might want to think about, the edible ones. Lots of really interesting work in the pharmaceutical area, in the cosmetics areas, where there is a massive demand for a high value crop, and where vertical farming again, either by itself or in that hybrid environment can bring you great value. I'd say for very much for what it's worth, that anything that we tell you, that I tell you, anyone else might tell you that sounds like science fiction in the way that vertical farming is going to go, well, that probably won't happen. But anyone that tells you that the way that we do farming today is going to be the same tomorrow, well, that certainly won't happen. It's an easy thing to say, but it's a truism, but it's true. The world is fast changing. There are massive pressures with climate change on this planet, and the way that we farm today is just not going to be sustainable. We are going to have to find better ways of doing it. But anyone that wants to give you a prediction of what that's going to look like much beyond next year, well, they're a better man than me. I would also say, again, it's a truism. I don't think it's a blinding flash of inspiration. We're still a very, very early stage industry, certainly as far as I'm concerned. We've seen only just this week some pretty large fundraisers, certainly large by the standards of our industry, in farm, raising almost $200 million, for example, and that's very exciting. It's exciting for everyone in this industry. It's very exciting for us. But I think that if you look at other mature industries, you don't really see maturity until you see the people that are raising this money then going out and buying some of their rivals up. And I think that the moment you start seeing that, you start seeing some of these companies that are getting Series B rounds, Series C rounds, Series D rounds, whatever it might be, turning around and buying up smaller rivals or even the same sized rivals into partnerships. That's when I think you'll start seeing maturity. In general, any industry, and if you look back to say the aviation industry in its early stages, or the automobile industry, there were tens and hundreds of competitors making the end product. And now in aviation, there are 3 or 4 manufacturers in aircraft, and again in the automotive industry, there are 8 or 10 serious players at most. So my prediction, and again, predictions, take what you will be that what we will see is a consolidation. You'll see a number of winners, and clearly a lot of people that will fall by the wayside, even companies that look quite exciting today. But just to leave it on a really positive note, because I am very positive about this industry. It's a hugely exciting one to be in, because we're at an early stage. There is a huge amount of opportunity. And if you have good ideas, you should get into this industry, and you should grab the opportunities with both hands, because these are big problems to solve, and they are some of the most important ones facing the planet to solve. So if we could do that together and in partnership, we should. And I'll just close by saying that we at Liberty, we have built this business in the short time that we've been operating very much in partnership. We have a whole number of partnerships that operate right now, and we are always open to talk to anyone, if it's just to give advice or to work with them on an exciting project. We're always open to that. There's a picture of our team there from our opening day, and there are my details, and you can find us on the website, and you can contact any of us on LinkedIn or Twitter, all those other social media channels, and don't hesitate to reach out. Thank you very much. I'm not sure, I should have took my watch off to check whether I was over time, but thank you for your attention.
No, I think that's perfect, actually. Yeah. So to finish in almost 15 minutes. So that's very good. Any questions? So we have a couple of questions come in. The first question, if I sort of ask you, is, in some vertical farms, there are no labor. How does it get executed? So that's the question.
No labor.
No labor.
So
I'm not sure what that means.
Oh, so fully automated. No
fully
people.
Automated, in other words. Yeah.
I'll caveat by saying that I'm not a technical expert. In fact, the next speaker, Dr. Bromley, I know that she's working a lot of automation. Maybe I could pass it across to her after her presentation. It's certainly true that vertical farming is one that has the opportunity to reduce labour. That's absolutely true. I think that robotics and automation in all industries are still, again, very much like Agri-Tech at an earlier stage. So I'm personally slightly skeptical of the idea of something being fully automated and not requiring any labor at all. I think that's a little, again, back to science fiction. I'm sure it might come at some point. So I suppose I might respectfully hand over perhaps and pass the baton in a few minutes' time to my esteemed colleague, and I should say also very near neighbour, because our facilities are just a few minutes away from each other down the road. But sorry, I'm sorry that wasn't a very good answer.
Okay, good. Thank you. And the second question here is, let me just see, my scroll is not working very well here. So I have seen various forms of vertical farming over the last 20 years. Mostly they grow lettuce and herbs, but they all have the same issues. How do you get a strong plant with flavor?
Yep.
And I think in the in the open, it is wind and climate that strengthens the plant. Yeah.
Yes. And again, I'm delighted that I'm going to be able to hand that over to Jennifer shortly, because she absolutely is an expert in that. And it's true. And you can see in the picture of there, those are leafy greens. I'm not going to hide that. What you can do, and where vertical farming does allow you to do the same thing, it's a combination of the lighting, and that control of that full spectrum is hugely important in that. The nutrition, of course, is hugely important, and you can be very, very specific now in what you do. As I mentioned, we've got a 12 VAT control system, so that's you can do some quite incredible things with that. So I think technology is getting better and better in the way in which you can absolutely get that flavour element now in modern vertical farms. I think that is certainly something that the technology that we're working on, the technology I know that, again, that Jennifer at Vertical Future is working on. We feel that between us and some other people as well, we're pretty much on top of that right now, though there's always more research to be done.
Thank you. That's very good.
Just to butt in here, sorry. Just to say, I will definitely be covering that. So
thank God. See, I was teeing you up, Jen.
Teeing me up.
Well, so
good.
Faisal, I will share my screen, and could you please introduce our next speaker?
Okay.
Can you see my screen?
Yes. So we have our next speaker, who is Dr. Jennifer Bromley. She is the head of plant research and development for Vertical Future. So Vertical Future is a company which is based in London, I believe. And Jan leads the research agenda to support the company's aim to improve the health of urban population through greater access to nutrition, locally grown crops, and so on. Her goal is really to develop technologies which Vertical Future installed for others. I hope I said the right thing in a nice summary way. Jen, so I'll leave you to start presenting.
Great, thank you. I'll just share my screen and pop it into presentation mode. Great, so can you guys see my slides?
Jen, can you please quick swap displays, because I your notes now.
How's that?
Great. Yeah,
perfect. Great. So I just want to say thank you very much for the invite today. It's great to come and talk to you guys at the Innovation Forum. Just a bit about me. So I have a PhD from Cambridge University. I studied in the Plant Sciences department, and I'm actually speaking to you from my front room in Cambridge right now. As Alex said, we do work just about a 2-minute walk down the street from one another in London. And a couple of weeks ago, we met up to discuss make sure that we'd covered the different areas of vertical farming and that we wouldn't overlap too much. So hopefully some of the questions that were coming up that Alex didn't want to sort of bat away, I'm going to be able to cover for you. So my focus today is on where to innovate and the science that supports the innovation directions in our industry. So essentially, what is the evidence that supports and directs where we're going? So just a little bit about our company. So we're Vertical Future. We're a technology-driven vertical farming and research company. And as Faisal said, we're based on building a healthier future for our planet and our children. We were founded in 2016, and we actually started off as growers. So we started with a off-the-shelf system that we bought in, and we started growing microgreens. And as Alex mentioned earlier, this is very much the paradigm that many people in vertical farming have fallen into. Microgreens are a high-value but niche product. We're lucky enough to be based in London with a lot of very expensive, fancy restaurants, and so we're able to market our crops into them. However, in the process of growing these crops, we came to realise that we needed to innovate, and we needed to work around the sort of the problems that we were facing. So we were finding a number of issues with the current technologies, and we decided to build better farms for us to use. So born from our own internal needs, but it turns out the sector wants them too. And so now we work to build farms for others as well as ourselves. And so why innovate? Much of the current technology for vertical farming has been co-opted from greenhouse growing. And that's a very different type and intensity of production. So in our hands, these systems had low levels of flexibility. So if you wanted to flip what you were growing, it's very difficult to do so. So whether that's a seasonal trend, so whether you see chefs changing what they want to grow, what they want to put into their food, or whether that's a massive market shift like we're seeing with the current COVID crisis, it was very difficult to respond to that. They also have very high capital and operational costs. And as somebody asked in a question earlier about automation, automation is going to reduce your operational costs. It may increase your initial capital outlay, but it will reduce your operational costs over the long term. And the result is that most vertical farmers at present are stuck producing this niche, high-cost produce. And the more farms that come online, the more price erosion that we'll see, and actually the more vertical farm producers that we'll see go bump as a result. So to make it a viable mass market production, we need to cut the costs of production, and we need to cut the costs through innovating. And they need to now be comparable to what I would term a broadacre or a field-grown crop or a greenhouse-grown crop. So the areas for innovation, they're basically subdivided into two different sectors. So you have the technology-focused innovations. So that can be within the lighting, within nutrient delivery, irrigation, or your system infrastructure and feedback. So like your sensor innovation and areas like that. And for your crop-focused innovation, that's very much based on your variety development. So things like dwarfing your varieties or producing more rapid cycling varieties. So like Alex was referring to earlier with the work that they're doing at the JHI with the blueberries, and also things like self-fertile varieties. So 3/4 of the crops that we produce for commercial for consumption rely on a pollinator. Now, if you're growing indoors, you don't have that casual sort of bees coming past, and you don't have that pollinator activity. So self-fertile varieties and other methods of pollination are very important to making sure that you can produce fruit or seed crops indoors. There's also another option of looking at heirloom varieties and repurposing them. But as you can imagine, this requires two rather different sets of skills. However, both require a thorough understanding of the end product, and that's the plants that we grow. So my plan for the rest of this talk today is to discuss with you guys about plants and the plant biology, which has served as inspiration for the innovations that have or are going to make dramatic impacts to the sector. So the first area of innovation I want to talk to you about is Lightsource innovation. So the application of LEDs for growing plants was pioneered in the 1990s by NASA. And the scientists there were looking of low energy ways to grow crops in space. Essentially, how are you going to feed your astronauts on the way to Mars? Because taking a seed into space and growing it is actually a lot easier than taking a fully grown plant and trying to keep it fresh. So early LED innovations centered around chlorophyll as the key photosynthetic pigment. And you can see from the spectra that's on the slide here that chlorophyll A and chlorophyll B generally absorb in the red and the blue light sectors of the wavelength. They reflect green, and that's why plants generally appear green, is because of the action of chlorophyll essentially not absorbing the red, the green-yellow region of the spectrum. And so the thinking here is that energy savings can be made by not providing these reflective wavelengths. So to start with, and still in use in many vertical farms, and including in my picture when you see me at the start of the presentation, LEDs are dominated by red and blue diodes. The theory being that if you're not providing the reflective wavelengths, the energy conversion to plant light, from light to plant biomass, is much more efficient. However, chlorophylls aren't the only photosynthetic pigment class that you see in plants. So if we look at something like a carotenoid, like beta-carotene that's shown here on the spectrum, they actually absorb in the green, yellow, amber region. And this, they do contribute a little bit towards photosynthetic yield. So primarily plants are using carotenoids, such as beta-carotene, as a photoprotective mechanism. So they're actually using them to dissipate excess light energy and to protect themselves from free radicals and reactive oxygen species. They're also responsible for the wonderful colours that we're hopefully about to see in the autumn. So the reds and the yellows that you see in the autumnal leaves, that's your carotenoid content. However, in humans, we know carotenoids as antioxidants, and they also serve the same purpose to protect against tissue damage in humans. And so they're actually a beneficial addition to our diet. And it's not just carotenoids that are light responsive. There's numerous other photoreceptors which respond to different wavelengths of light and have effect on how the plant grows. So things like cryptochromes and phototropins, they're critical for anthocyanin biosynthesis, and these respond to blue and maybe even green light. And anthocyanins are another antioxidant, and you'll know them better for the blue and red colours they give to crops like blueberries and raspberries. So by adding in other wavelengths beyond the blue and the red, quality and quantity gains can be made. So in the study on the left, you can see that by supplementing in green light for blue light, the degree of non-green pigments in these lettuce types changes. So the more green light that's added, the red variety of lettuce, this Ruxai variety, you see actually gets less red. So the more green light that you add, the less red pigment that you have. And also you can probably tell that there's a very different leaf morphology. So when you have a higher proportion of blue, the leaves are actually slightly smaller than when you start adding back in green. And so for leaf crops, these features can be really important and very much impact the price per kilo that a supplier is willing to accept. Excuse me. So in the study on the right, this is a quantity question. So here, the scientists who were carrying out this work, they were supplementing in red and blue light, which is on the far side, with an additional white LED. And what you can see is per head of lettuce, you're seeing approximately a 30-gram difference between red, blue only, so that sort of traditional sort of pink vertical farm light, with a full spectrum addition. And over the course of a year, and at a very conservative estimate, per metre squared, you could be looking at an uplift in production of around 30 kilos per year. So this is quite a large gain to make by simply adding in a few more wavelengths at a very low energy cost. But there's also work that's been going on beyond the visible spectrum. So this is working with things like UV light and infrared light. We know that plants respond to UV and infrared. And UV has been shown to be a driving factor in flavour differences between outdoor grown and indoor grown herbs. So if you look here at this gel that was carried out, what you can see is when you add in UVB light to an otherwise only visible spectrum, you get quercetin appears. Now, quercetin is a flavanol, and these are responsible for compounds that confer bitter tastes in edible plants. They also have antioxidant activities. So if you look at it from a greenhouse grower perspective, which is a form of controlled environment agriculture, the UVB in sunlight is filtered out by the glass of the greenhouse. So a simple supplementation with a for coriander, I'm not that interested. I'm one of those people that thinks coriander tastes like soap. But for other people, I'm assured that this is a delicious addition to your coriander. But if we look at the more plant breeding side of things, there's a lot of different ways that you can adapt a crop for vertical farming. And I don't have time to get into everything today in just a short period of time, but essentially they fall into two groups. One group, the plant architecture and growth, that's essentially, can you make it work in a vertical farming system? So, for example, a very, very tall, sprawling plant is not going to work as well as a short, dwarfed variety. Equally, something that cycles rapidly and grows rapidly and develops rapidly, for example, the blueberries that Alex is talking about, that's going to work better in a vertical farm than something that cycles much more slowly. Equally, things that are easy to harvest and have small root systems work better in a vertical farming system. Particularly if you're looking at growing a fruit crop or a leafy crop, you don't want the plant to invest all its efforts in producing a root system when you want it to put its efforts into producing what you're going to make your money out of. Now, a lot of effort's going into plant breeding for all of these traits, though without things like new breeding technologies such as CRISPR and gene editing, these are going to take quite a while to come to fruition. So from a typical timeline to market, a new variety would start at around 4 years. And for me, from my background, my PhD was in potatoes, and I've worked in various different solanaceous species throughout my career. That's actually incredibly quick. I'm more used to something that's in the region of 10 to 15 years to bring something to market. So in order to make those gains quicker, we can actually look to the past. And that might seem counterintuitive, but a lot of the recent breeding efforts for field or broadacre farming have focused on pathogen resistance and tolerance. And there's often a trade-off between resistance and yield or flavour. And so in a crop like spinach, which massively impacted by a pathogen that we call downy mildew, there's a trade-off between this resistance and yield reduction. And it's an absolute no-brainer if you're working in a field variety, because 100% of your crop can be lost if you are infested with downy mildew. So it makes no sense for a farmer to grow one of these older varieties, which has much more susceptibility to a downy mildew. But within a vertical farming system, where we're fully enclosed, it's a controlled environment, we don't have the pathogen pressures that a field farmer would have. The question is, can we make use of these susceptible out-of-favour cultivars and make the benefits and make the gains of the yield or flavour that these might offer? And there's a lot of work going on, and we've actually just started a research grant with 3 other participants for the next 2 years, where we're starting to look into that, particularly with relation to leafy crops that we know are highly pathogen susceptible. So to summarise, there's a myriad of technological and biological improvements that could be made to improve the cost effectiveness of vertical farming and bring more produce to the mass market. But critical in deciding this path to make the improvements is having an understanding of the biology behind the crop we're growing and working with that biology and not against it. So with that, I'll thank you for listening. I'd like to thank the organisers for inviting me to share my thoughts, and I'll take any questions.
Thank you. I think my network is not very good, so I think Yisu will ask the questions.
Yeah, thank you so much again, Jen, for your amazing talk. It's on the personal level, it's very inspiring. So we have quite a few questions. I'm just gonna ask them away. So scroll up a bit. No. Rayan asks, which saves more energy, greenhouse or the vertical farming?
So that would depend on what you're growing. So a greenhouse, obviously, in the height of the summer, you're not going to be inputting light energy because you can use the sun. However, in midwinter, you're going to need heat, you're going to need light in a greenhouse, just like you would in a vertical farm. The benefits of vertical farming are that you can have multiple shelves, multiple layers. So whereas in a greenhouse, you're essentially, you're stuck on one level because you're using the sun, you're using energy that's coming from outside. So you'd be looking at, it's a different system. So I'd say it's difficult to say. Both use energy, but they use energy differently.
Yeah, great. Thank you. So we have quite a few questions. So if you can just answer them. Ooh, and more are coming. So Faisal asked if vertical farming will be an integral part of our future life.
So as somebody who works within a vertical farming technology company, I certainly hope so. I would say that within the current sort of agricultural system, we rely an awful lot on importing plants, importing our food, or we grow it in one area of the country and we move it around. There's a trend towards localizing food production. There's a trend, there's a great push from the government towards net carbon zero by 2040. And so through localizing food production and reducing your food miles, that is one option and one route towards it. I honestly wouldn't be surprised if it becomes a much more of a focus for smart buildings, particularly for offices with large canteens, for large business parks who might be looking to feed and to sustain their local population. I'm seeing that as going on. We are working on a number of different projects around the world where this is essentially part of the drivers. It's about localizing the food to the consumer.
Great, yeah, thanks a lot. So I think I'll just take one more question, and then all the other questions we will put them at the end because I think they are amazing discussion questions where everybody could have a say. So the last question for you, Jen, is compared to current agriculture systems, how/to what extent does vertical farming improve the efficiency of time/resource? And there's a follow-up question. So if you want to just answer that bit first.
Okay, so compared to like a field agricultural system, you can be much more precise with your resource use. So for example, rather than just chucking on your nutrient and your fertilizer at certain times within the cropping period, within a vertical farming system, you can use sensor technology to monitor the health and the growth of the plant. And so you can target your nutrient delivery to a very specific time in its growth. So you can be much more distinct about when you choose to fertilize and when you choose to irrigate. In our hands, we're seeing a massive reduction in the amount of water that we're using. I wouldn't like to put a number on it at the moment. There's a lot of numbers are bandied around. People talk about 95% water use reduction compared to other types of farming. But that's not a number that I've sort of substantiated, and I wouldn't like to sort of set my stone on that. But there is a large energy, water and nutrient sort of saving that can be made through farming in a much more precise and controlled manner.
Great, thank you so much, Jen. I'll just go ahead and introduce Ian, and we will answer the next question as a discussion. Thanks again for your amazing talk. So I'm just going to quickly introduce Ian Cox. Ian is really someone who doesn't need too much introduction. I mean, Ian manages the delivery of a 90 million pounds capital program with match industry funding to develop a series of leading-edge centers for national and international agri-tech innovation. And he has a previous experience as the Scottish Centre of Expertise in Plant Health. So Ian, if you would like to begin your presentation. Thank you very much for coming.
Right, thanks very much. Thanks very much for the invitation, and good evening to everybody. Can you all hear me okay?
Yes.
Good, okay. Right, yeah, I'm going to take a slightly different tack tonight because Jen and Alex have already covered what I would probably have talked about already. So rather than so don't bore you too much with what they've already said on that side, saying it a third time, I'm going to talk about the importance of agri-tech within agriculture and also sort of point out some of the funding opportunities that we've got out there. So I'm going to briefly talk about Innovate UK and UK research and innovation, a little bit around Agri-Tech, some of the challenges that Jen alluded to before, and how we're sort of stimulating investment into vertical farming and traditional farming. Let's not forget that's still there. It's still got a very important role to play, and also food health, food safety, food health, food improving food nutrition, etc. along the way. So Innovate UK is one of the 9 research councils, if you're within UK Research and Innovation, or UKRI as it's called. So collectively we invest over £7 billion a year in research and innovation. We, as Innovate UK, fund industry. We're different to the others, which all fund academia by and large, with industry tagged on. We're the other way around. We are the applied innovation agency. So we're there to make the impossible possible and help to deliver knowledge with impact. Within Agri-Tech, we funded well over 400 projects over the last 10 years, industry-led projects, some of which are becoming extremely successful out in the marketplace, and delivering results in this country. Some of the companies that have had our funding have actually been bought up by foreign investors. They've like what we've done so much, have actually sort of paid a lot of money to buy some of the companies over here, and the Treasury quite like that because they get a percentage of the tax revenue that goes back. So it's a nice little sort of circle around the funding opportunities on that side. So we're there to help create knowledge with impact, and we're funding projects currently in the controlled environment agriculture and aspects of vertical farming, as well as traditional agriculture. So Agri-Tech, you can't really sort of say that agriculture is a simple system out there, unlike, say, building a car or a jet engine or anything like that. That's relatively straightforward to do. There are so many different variables, and it's so interactive, really, crops, livestock, and that includes aquaculture there. Alternative proteins and alternative feeding now. I mean, Europe has a huge sort of protein deficiency in terms of growing its own, so we have to import a lot of protein, typically things like soy, to feed animals on in the UK. A lot of that is indigestible for animals. It causes all sorts of illnesses in animals. It's very environmentally damaging to grow it. For instance, in Argentina, they've stopped growing crops and livestock on the pampas down there. They're growing soy, which is totally wrecking their soil in comparison. So you get these changes in what's happening there, but the environmental impacts of some of what we do are extremely severe. I mean, Jen mentioned it before about the damage that goes off, but within agriculture, we have got to sort of learn how to feed. Currently, we're about 7.5–8 billion population in the world. We've got to be able to learn how to feed over 10 billion people by the time we get to 2050. When you think it's only 30 years off, it's not that far off. And we've got to do it with the same amount of land that we've got currently, or possibly even less, as cities start to increase due to all these people that are out there. And we've got to reduce the amount of greenhouse gases down to hopefully net zero by about 2040 is the ambition in the UK, 2050, 2060 for the rest of the world. So we've got some big challenges. When you look at the food out there, to feed the 10 billion people, currently we produce about 2.1 billion tonnes a year of cereal worldwide. And we're going to have to increase that to over 3 billion tonnes to be able to feed people. And meat consumption, a lot of people are saying it's bad to have meat, but we can't get away from the fact that meat is a useful source of protein and provides a lot of nutrients. And meat production is going to double to over 470 million tonnes a year by 2050. So that's an awful lot, big increase in what we're going to do. And Jen mentioned before, the UK, we import roughly half the food into the UK. We can't sort of grow, can't use any more land really. We've got about 72% of the land mass is actually used to feed the UK, and we still can't do it on that side. So we've got real problems Water is another big issue out there. We want to be able to sort of grow crops conventionally like that. We use around 70% of the fresh water just for farming purposes like that. But the runoff from that does cause quite a lot of problems. Things like nitrogen fertilizers, if they get into the water supply, and I used to work in the water industry, we used to sort of look at the nitrate vulnerable zones, and Cambridge is a perfect example of that. If the ammonium phosphate fertilizers get down into the water tables there, you get this syndrome called blue babies, which means that babies can't breathe properly due to the interaction with the ammonia in the blood. So that is a real problem. So you want to prevent that from actually happening. And similarly, you don't want to sort of have soil runoff as well, because that sort of gets into the streams and the rivers and ultimately affects fish breeding grounds. And when you look, food production currently produces between 1/4 and 1/3 of the total sort of greenhouse gas emissions in the world. So we've got a hell of a lot to do to actually sort of get down to the net zero over the next few years out there. And of course, we've got things like COVID, which probably won't be the last pandemic we're going to have in the next 20 or 30 years out there, especially with airline travel the way it is, and we can get around the world under normal situations. So we've got a lot of things happening out there in what is a very complicated system to start with. And when you start to look at the landscape of the different kinds of capabilities and technologies that are out there, this just gives you a bit of an idea about some of the farming landscape that exists in terms of the different systems and capabilities out there. Everything from a lot of data and field monitoring. I mean, Jen mentioned about the problems in fields, about trying to measure various things. Well, people are developing a lot of sensors, and we're funding a lot of projects on doing that. But there's also joining everything up, getting the big data systems to work properly, artificial intelligence, getting it all working properly, and giving farmers the correct information they want to actually deliver, so they can actually deliver what they want on a field or in any other sort of farm settings. So the challenges we see really, net zero out there, obviously. We've got nutrition for health. I'm glad to hear that we've got some doctors on the call. Global agricultural trade is currently about $1 trillion a year, but there's a thing called sort of nutrition and food deserts that occur even in well-developed economies like the UK, the USA, France, Germany, you name it. And these nutritional deserts are causing bigger problems for healthcare than the agricultural trade. So they reckon that to cope with the nutritional deficiencies worldwide, it is going to cost about $3.5 trillion a year. So 3.5 times the cost of the agricultural trade that goes off worldwide. So it just puts it into context, some of the problems we've got there. We obviously want to have an efficient production system out there. There's this great phrase that John Beddington, the former government chief scientist, came up with called sustainable intensification. And that's really what we need to achieve. We've got to increase a lot more. We've got to increase productivity massively whilst at the same time being sustainable, and also look at balancing natural capital. So making sure that we don't wipe out the pollinators along the way. Food production integrity were and still are a big issue. Fortunately, countries like China in the past did horrible things like putting acrylamide into baby powder, trying to water it down to make extra money. Those people, I think, got the firing squad when they got found out about it. But we've got to stop people adulterating our food along the way. And a problem that we do have, not just due to COVID this year, we're going to have it in the UK, is around labour. We're currently about 60 to 80,000 people short on what we need to pick crops in the UK. Typically that's done by gangs that move around Europe to feed people. We're not going to have access to that come January in terms of because of Brexit, and we didn't have it this year. People were actually getting people into the country now to on that front. We're looking at biotech, so the idea around what can we do around accelerated breeding techniques there, sort of using CRISPR and other technologies out there, robotics and automation, innovative foods. You've heard of things like cell culture meat out there. There is a genuine desire to move away from some meats on that. So we are probably going to be funding more on that in terms of helping people to develop new techniques around that. Agribusiness, marketplaces, management sensing, Internet of Things. We're doing a lot of work on that currently, and that's one of the areas, one of the Agri-Tech centres I look after is working on. Bioenergy, biomaterials. Can we make plastic bags out of bio waste? Yes, we can, but we need to make them better and more usable and then recyclable. We want to improve the supply chain, and we're looking at novel production systems. So these are some of the areas that we're looking at and where we hope to be able to carry out more funding calls in the future. So as I said earlier, I look after the UK's 4 Agri-Tech centres. Now these centres join up a lot of existing research excellence out there, and we've invested in 55 new facilities and capabilities in the UK that don't exist anywhere else in the world, believe it or not. We had a review of the centres last year, and that point was really rammed home by one of the panel of experts we got in to review what they've been doing, and he said this capability does not exist anywhere else. We are seriously interested, and that's from Canada, so they're very keen on working with us over here in the UK. So we have Agrimetrics, and it is the world's first big data centre for agri-food. Crop Health and Protection Centre that Alex is involved with. CL Livestock, it is Europe's largest applied animal research group, doing something like 800 researchers, all looking at applied innovations around animal health, nutrition, welfare, reducing the amount of methane that comes out the back end of ruminants as well. Agri-Epi, which is focused on engineering precision innovation, carrying out all sorts of different projects out there. My little centres, as I think of them, yeah, we built 55 new facilities in the UK, and we've got 3 overseas, 1 in China, believe it or not, 1 in Paraguay and 1 in New Zealand. The one in New Zealand is actually delivering a lot of climate change data for UK companies and also the New Zealand government there. The one in China is actually looking at a holistic view of joining up the whole food supply chain, right from initial crops through to animals, through to food processing and onto the plate or into the rice bowl, in effect. So we're looking at something very major over there. The centres have been involved or are involved in around 240 projects, which are worth about £53 million to the industry. So they're catalysing that. We've not been able to fund that directly through core grant to the centres. They've actually had to go out there, competitively win those projects or engage with industry to do it. They have created well over 150 positions, and the odds are they're projecting to get up to over 1,000 over the next 3 or 4 years. And that's not just in the UK, it will be in sort of continents such as Africa as well. Got 240 organisations connected, everything through from micro companies through to multinationals. We've actually attracted an international company to locate its new R&D facility in the UK for the first time ever. So we're really pleased about that, but we can't actually shout about it because of animal rights issues on that side. They're worried about sensitivities on that. They're achieving on policy objectives, but most importantly, they are delivering real benefits to farmers already in the sort of 4.5 years they've been up and running. And don't forget, we haven't actually built all the facilities yet. We're still finishing them off. But they're actually helping farmers to get real benefits out of some of the work they're doing, such as 20% improvements in milk yields for one, reducing calf losses, new pen-side diagnostics. Sorry, they're all animals, but there are other ones coming along on crops. They're just a bit slower to see the daylight in the markets, really, on that side. Agri-Tech in the UK. The UK is now the #1 place to go to get venture capital and investment going. We're very pleased that some of the companies in there on the list on the right hand side have received Innovate UK funding, so it's very good to do that. Innovate UK is funding is seen as a bit of a badge of honour by banks and venture capitalists and follow-on funders from us like that. Sort of it does seriously improve the chances of getting further funding once you've had Innovate UK funding. There's a lot of evidence to show that along the way, so we're very keen that continues, and we're very keen as well that the UK is seen as the #1 place to come to for agri-food, agri-tech investment and applied R&D. COVID has had a big impact. For those people that are out there, we do offer a variety of different sort of support options for people that have got existing projects. So we're helping with continuity loans and also advisor support out there. You can have these slides afterwards. So if anybody has a company that has been caught up by COVID, please have a look at some of the information that we've got out there around the COVID-19 support that we can provide companies. We also have Sustainable Innovation Fund there. We're looking at the ways we can do anything to help companies to recover from the impacts of coronavirus. There was £10 million. We've got another, the call is open currently. There probably will be more funding coming available through this particular call. I think that closes next month. So get your skates on, have a look, follow the web link and go and have a look if you're interested in what funding's out there. We also have Innovate UK Smart Grants. So there's current call, I think, opened in August, and that runs through till middle of October, the open date for that. There will be others that follow on behind it. We will fund anything between 6 months and 36 months as project size. Now, smart grants, unfortunately, whilst they can cover almost anything and preferably be as disruptive as possible around the technology on that side, it does mean that you're going to be in an awful lot of competition. We've had 1,500 applicants on this particular call in one round of funding out there, so just be aware it is extremely competitive. If you do apply for funding with us, I would say think about it early enough, pretty early on. Don't leave it till about the last week before you start to apply and try and write your bid, because chances are you're not going to do very well about it. We also have Agri-Tech Catalyst funding for people that are doing projects in poor countries, typically in Africa. We do have round 10 of our Agri-Tech Catalyst funding programme is open at the moment. We have £2.5 million available covering these areas. So this is for collaborative R&D with partners in a range of African companies. Again, you need to look on the website to find out what companies are in scope, but most are, apart from I think South Africa, like that. So it's, and I think it's mainly sub-Saharan Africa that we can fund there. But there's a lot of interest in these about helping and developing new technologies and capabilities out in Africa there. We expect to have round 11. That will depend a little bit on the comprehensive spending review that's going through currently. Horizon 2020. The UK, despite leaving the EU, is still eligible to participate in Horizon 2020. And the way this was described the other day, the new Green Deal here, it's like the EU sort of realised it might have some money down the back of the sofa, rummaged around there and found some more money to spend because Horizon 2020 should have finished. So this is a one-off call that's open. It's just opened last week, really. So we have Farm to Fork is Area 6 there. So you can actually sort of apply for funding through there as part with European partners. You need to have a variety of different countries involved in the calls on that front. I would advise you to speak to the Horizon 2020 National Contact Point, who is part of the Agri-Food team at Innovate UK. And this gives you a bit of an idea of what they're looking to go for. Climate neutral farms, climate neutral food businesses, reducing dependence on hazardous pesticides, increasing the efficiency of fertilizers, reducing losses, move towards net zero or zero pollution of water, soil and air, reduce dependence on the use of antimicrobials in animal production and aquaculture, reduce food losses and waste. So vertical farming would fit quite nicely in this, around sort of reducing food losses, food waste, moving towards reducing the use of fertilizers and pesticides, etc. So this is an area that's out there, so I would suggest people to please explore the documentation and go for it if you're really interested on that. So in conclusion, realise I'm probably running out of time here, there's a lot actually occurring now. We do have a lot of big challenges out there, but we can do an awful lot to support. And apart from looking on the Innovate UK website as to see what funding capabilities we've got out there, I would urge you to sort of speak to the Agri-Tech centres. The Knowledge Transfer Network are a very useful source of support. They can put you in touch with partners if you need people to work with. Enterprise Europe Network, whilst it's sort of partly European Union funded, it's also UK government funded. They can provide you with a lot of support activities around developing your businesses, about moving things forward. And the Knowledge Transfer Partnership is probably the best job creation scheme we've got going for sort of graduates and postgraduates out there. It allows people that have got a degree to work with a company, as long as they've got the capability to lead a strategic project on that front. The company put money in, we put money into it like that. And the result is that the student or the graduate gets a three-year posting and grounding in industry and can lead on a major strategic area of expertise. The company gets the benefit of it having its problem solved. The university gets know-how and knowledge of what's actually occurring in industry. It's a bit of a win-win all round. And we would advise people to look at knowledge transfer partnerships as a good way to fund things. You need to put in between £35,000 and £55,000 into a KTP over up to a 3-year period to deliver on that. So we have lots of different funding mechanisms there to help people to deliver, and there's a lot of support out there that Innovate UK and its colleagues can tap on to help you develop what you want to move forward with. So with that, I'd just like to say thank you very much, and hope you found that useful.
Thank you so much, Ian. It's, I mean, from a personal perspective, again, it's incredibly useful. So we just have a very quick question for you. It's from Mariko, asks, are these predictions referring to, I imagine, the prediction that you were talking about at the beginning of your talk, based on trends over the past decades? New trends?
The move to the 10 billion people. Yeah, that's come from the UN, from one of their agencies there. They've looked at the population statistics. It'll probably peak at about 10 million people and then start to go down, because when you look worldwide, birth rates are dropping, and in countries where people have traditionally had high birth rates, as women have become more educated, you're actually starting to see the birth rates reducing on that level. So probably population is going to peak at about 10 billion people like that, and as we all start to get a bit older and start dying off, it will come back down again. But for the next 30-40 years after that, we're probably going to remain around 10 billion people. Then it will start to decline. So there's quite a lot of we've got a big problem coming up. If not, we're probably going to have a lot more sort of revolutions going off around the world as people get a bit hungry, and they don't like hunger. I think the phrase Trotsky sort of said, we're 3 meals away from it, 3 meals away from revolution. In the book Good Omens, on the television series last year, they actually sort of said we're 24 hours and 2 meals away from revolution. So it's not far off, whoever you want to believe like that. the world.
Yeah, I think the COVID has taught us basically the one thing really matters is food. Yeah.
It is. At the end of the day, we need food. Without that, everything else becomes immaterial. Dare I say it's sort of COVID vaccine. If we've got a starving population and people are dying of malnutrition, getting a vaccine for COVID is probably the last thing on their mind, really.
Exactly. So I think in the interest of time, we should move on.
Okay.
Yeah.
Thank you very much.
I think there's another question for you, Ian. I think it's quite an important one. So Jonathan asks, what could be the potential economic impacts of localizing food production to reduce carbon output for other nations which may rely on agriculture?
In terms of carbon impact, it's going to be a percentage of that sort of 25 to 33% that we produce currently like that. The biggest impact is probably going to be the profitability for companies because the sort of delivery costs are getting more expensive, and if you like, the last mile is probably the most expensive part of it, to get it either to store or to using Ocado and other delivery services to people's front doors like that. So that's where the problem's going to be. If you start to localize your food production near cities, you've got the economics then start to get a little bit different, because you've got to look at what the balance is in terms of building your farm close to a city versus using that land for other economic purposes, such as a manufacturing plant or an office block or something like that, or a university. So it depends where you build it, and repurposing existing redundant facilities in cities or near cities will be the best way to go forward, really. It sort of cuts your costs massively. So there are some vertical farms in the UK that are built on industrial parks using old cold stores and things like that. They're very well insulated, so it cuts your build costs massively, and they've got good power supply, so it helps reduce your infrastructure costs getting those up and running. So working out what the carbon impact on it is would be difficult. You'd need to do a proper life cycle assessment model of it to actually work that through.
Cool. Yeah. Thank you so much for your question, for your answer.
Okay.
In the interest of time, I'll just quickly introduce Ahmed. Ahmed is he's a fellow Canadian, if I'm not mistaken. So I'm also from Canada. I see that you have your qualifications from McGill University. But what I'm really impressed with about Ahmed's work is he's one of the if I may say so, pioneering person of cellular agriculture. He authored a book called An Introduction to Cellular Agriculture, and he's a co-founder and member of the board of directors for Cellular Agriculture Canada. So without further ado, Ahmed, can you please share your screen?
Hey, thank you for that wonderful introduction.
Thank you.
Can you see my screen?
Yeah.
Hey, perfect. Well, hi everyone. My name is Ahmed Khan, and I'm the founder and editor of Cell Agri. Before starting, I just want to say those were incredible talks by Jen, Ian, and Alex about Agri-Tech investments and vertical farming. In terms of comparison, it would be interesting to see where vertical farming was 5 to 10 years ago and compare that to where cell agriculture as a food technology is today. So to begin, I want to share a brief introduction to cell agriculture, as well as a brief overview of the UK cell agriculture landscape, and address some potential opportunities in the ecosystem of the UK for future founders, investors, and even corporates to get involved in. But before diving into that, I want to share some more information about how I first got involved in cell agriculture and some more information about Cell Agri. I first learned about cell agriculture in 2017 at the end of university, and I was blown away by the concept and the field. Following school, I tried to learn as much as I could about the field, the latest news and updates, the insights, the company listings, and even opportunities to get involved with the field. But I was having a problem at the time. There was no one-stop website or tool that had all the information I was looking for. It was even hard to find out what news was even relevant at that point in time. And that's how Cell Agri began, to be the news and market insights platform focusing on the future of food with cell agriculture. We track and promote all the different players in the ecosystem and share all our insights with our subscribers. One of our goals is to become a homepage for the cell agriculture field, where people can come to learn anything and everything about cell agriculture, from what it is to who's involved, and the latest market insights and opportunities in the field. Like mentioned, I previously published the first Introduction to Cell Agriculture ebook last year to further raise awareness of the field. The ebook is an in-depth overview of the field, from what it is and why it matters, all the way to common misconceptions about the field and obstacles moving forward. We also list out different companies and players in the field. If you're interested in downloading a free copy of the ebook, you can visit the Cell Agri website at the end of this webinar to go and get it. Along with the ebook, one of the projects I've been working on currently is taking a look at the global cell agriculture investment landscape and some of the technological innovations required to help grow and scale the field, and especially when it comes to the idea of cell cultured and cell grown meat. And when it comes to the cell agriculture landscape here in the UK, many companies and players are working to actually address those technical challenges. Oops. I don't want to take too long, but for those who are hearing about cell agriculture for the first time, I want to touch on the benefits of cell agriculture and how we can use it to build a new food system that can be better for everyone. So cell agriculture is the field of producing animal products like meat, like dairy, and leather directly from cells instead of raising animals to produce the same products. Compared to conventional animal agriculture, cell agriculture provides a more sustainable and environmentally friendly way to produce the same products to meet the growing demand for animal products like meat. And besides the incredible fact that it is possible to grow food directly from cells, cell agriculture is going to be critical in developing a sustainable food system for our future. Our current agriculture system has produced enough animal products to meet current demands, but it will not be able to keep up with future demands, especially with a growing world population. It is predicted that the global population will be between 9 and 11 billion people by 2050, and the global demand for meat is predicted to skyrocket from approximately 60 billion animals in 2016 to over 100 billion animals by the year 2050, essentially nearly doubling in the next 30 years. So we need cell agriculture to help us produce a more sustainable food system to meet that growing demand. And typically we break down the benefits of cell agriculture into a few categories, such as reducing the amount of resources required to produce animal products, public health implications, and improved animal welfare conditions. In light of the devastating impact of COVID-19 around the world, I also want to highlight the food security aspects of cell agriculture. COVID has really highlighted the needs for resilience in our food supply chains to ensure people do not lack access and availability to their food needs. And cell agriculture can help address that by being a way to produce food locally, anywhere and everywhere on the planet, and hypothetically in space as well. Food security has not really been a major popular conversation in Canada, in the US, and I imagine in Western Europe until the pandemic. But food security is actually a major reason why there's a major interest in cell agriculture in Asia, particularly in Singapore, Japan, and across the Middle East. Without requiring as many resources like land or water, countries that rely heavily on food imports can now produce enough food locally for their populations. So how do we exactly produce meat from cells? This slide just gives a visual breakdown of how the process works. Scientists would take a small biopsy from the animal of interest, like a cow or a chicken, and grow those cells in their facility. Some of those cells would include stem cells that have the ability to self-replicate and divide indefinitely to become more cells that can become the meat product. These cells are grown in a cell culture growth medium that helps the cells believe they're still in an animal, and therefore to continue to develop into the cells you find in meat, like they would in the animal. At scale, the cells and the cell culture nutrient formulation would all be placed in a bioreactor where the cells would grow and mature into meat. The bioreactor may also include scaffolding that can help provide structural support for the cells. So essentially in that way, the bioreactor is just a complex chamber where everything comes together to form the finished product, a cell-grown meat or cell-based meat. And I wanted to highlight this process of how cell-based meat is made because it is relevant to understanding the UK cell agriculture landscape. Unlike the US and other places around the world, the UK cell agriculture landscape is a bit more unique. There are more startups looking to address problems in scaling the field of cell-based meats by addressing these steps than there are startups actually focused on producing a meat product. I also want to add, if you're interested in seeing more of these fascinating graphics that break down some of the key terms in cell agriculture, do follow Cell Agriculture Canada on Instagram. They do great work there. And as mentioned, I'm a co-founder of the nonprofit. So as I mentioned, the UK cell agriculture landscape is different from the US because there are more startups looking to address challenges in scaling production in the field instead of producing the meat. The only startup looking to produce meat from cells in the UK is a company called Higher Stakes, that actually just moved its base to Cambridge in the last year. Higher Stakes uses cell agriculture to produce cell-based pork, and this summer, Higher Stakes became the first company in the field to produce a prototype of a cell-based bacon and cell-based pork belly. Cell-based pork is particularly uniquely positioned these days, especially considering the devastating impact of African swine fever has had on pig and pork populations in China and all around the world. According to Benjamin Abolog, Higher Stakes CEO, the pork belly product contained up to 50% cell-based meat, and the cell-based bacon contained up to 70% cell-based meat cells in the prototype. The rest of the UK landscape focuses more on some of the technological challenges in the production process that was mentioned on the previous slide, like bioreactor technology. One of the oldest companies in the UK is, funny enough, called Cell Agriculture Limited. The company was founded as a spin-off from Bath University by Dr. Marion Ellis and Ilse Dunsford, and their startup focuses on developing bioreactors for the field. While they're one of the oldest startups in the field, one of the newest players in the UK is another university spin-off called Cellular Revolution. Founded as a spin-off from Newcastle University, they also focus on bioreactor development. So as you can see, bioreactor development is an important part of the field, and they've both actually received funding support from Innovate UK. For the field to be successful, the field will need to develop large-scale bioreactors similar to large brewery tanks we can see when visiting a brewery, to produce large amounts of cell-based meat to be commercially viable and affordable. Currently, no large-scale bioreactors exist to accommodate the scaling of cell-based meat production. So it's important that more startups emerge, like Cellular Agriculture Limited and Cellular Revolution, to continue to work on that. One of the newest startups in the UK is a group called Multis-Media, and they're working on developing an affordable, scalable, and animal-free cell culture growth medium through which is the nutrient broth that animal cells would grow in the bioreactor. When talking about the cell culture nutrient formulation, like on the previous slide, I'm referring to the cell culture media, which contains ingredients like vitamins, minerals, growth factors, and most importantly, the cell culture serum, which provides most of those ingredients. There are currently two main obstacles in scaling cell culture serum: its sourcing and its price. In many scientific labs, a common source of cell culture serum is called fetal bovine serum, which is a challenge for the field because not only would this still require animal sourcing and animals in the whole production process, fetal bovine serum is very costly and can vary in quality from batch to batch. And when you're considering that the industry aims to have bioreactors one day to the scale of 20,000 liters, it's very important to find an affordable and inexpensive cell culture media that works for all different types of cells and all different types of meat for the future. So it's no surprise that developing an affordable cell culture media is considered a holy grail for the field. And before moving on, I do want to highlight a few nonprofits and groups in the UK, like Cultivate UK and Cell Agriculture UK, for playing a key role in raising awareness of and explaining the field to a wider community in the country. So with the global growth of the field, and including in the UK, what are the opportunities to further grow cell agriculture in Europe, and particularly in the UK, to make the country a leader for the field? UK and European scientists and founders have played a big role in helping get the cell agriculture ecosystem to where it is today, but there's more to be done to make the UK a leader and a key hub for a future food system. Considering the current state of the industry, of the cell agriculture industry, we highlighted 3 areas of opportunities that can make the UK a leader in the emerging field for the future. I don't want to take too much time. I just want to touch on the role that corporates can play in the future of food with cell agriculture and further grow it through partnerships. Supply chain development, like addressing some of those key pain points, is going to be critical for the field's success. And partnerships with established players in the food, agriculture, and even pharmaceutical industries can help support the field's growth while finding their own footing in the nascent industry. As years progress, we will likely see more conventional agriculture, meat, and even pharmaceutical players explore how they can apply their expertise and their technologies into the cell agriculture supply chain. Not only would this help support new startups in the field, it will make sure that these corporations continue to play a role in our future food supply chains and even present opportunities for pharmaceutical and even biotech companies to get involved in our future food supply chain. So as you can see, there's still many hurdles that the field will need to address to scale, and partnerships with established industry players can help address that. So I don't want to take too much more time here, but as you can see, the field of cell agriculture has grown in the last few years, and more UK startups are emerging to help change our food system with this technology. And interestingly, none of that would have been possible without the role that the UK played initially in the field. It was actually in 2013 when Dutch scientist Dr. Mark Post showcased the first ever cell-cultured meat burger in London. In an audience full of journalists and the media, the world saw for the first time the first ever cell-cultured meat burger in London. Since then, the field has exploded globally, and we have scientists and entrepreneurs all around the world looking to use this technology to make a more sustainable food system. If it wasn't for that first taste test on a global platform like London, would the field have grown as much as it has in the last few years? It's hard to say, but presenting in London, a global leading hub, has definitely played its role. I want to thank you all for taking the time to listen to my brief exploration of the UK cell agriculture landscape. While there are not as many startups looking at both cell agriculture as they are in the UK or even vertical farming, the UK has played its role in developing and advancing the cell agriculture field. If you're interested in learning more about cell agriculture or cell agri and the work we're doing, please feel free to reach out to me at ahmed@cell.ag, and feel free to sign up on the Cell Agri website for the ebook or regular newsletter. I'm going to pass the floor back. Thank you very much.
Thank you very much, Ahmed, for a very amazing talk. I just have three, four. I can't even count. Okay, so just have a few quick questions for you, and then we will jump into a Q&A panel session. So the questions for you is, so first Rayan asks, I think it was when you were talking about FBS, he asked whether it is cloning animal cells.
So cloning, that's a really great question. Cloning is a different way of looking at application of biotechnology. This field is just using stem cells from different animal cell lines to grow and divide into producing a range of different types of meat products. If it was one specific type of product looking for, cloning would be a more appropriate manner, but this is slightly different than that.
Cool, thanks. So let's go to the next question. Are there any unknown food consumption safety issues with cellular food product? I think that's a very nice question.
That's a great one. Currently, companies that are exploring producing cell-based meat and other cell agriculture products are working with regulators in their respective countries to make sure that they can come up with a safe and appropriate regulatory process to make sure that the products are safe and healthy and just as tasty as conventional animal products.
Great, thanks. I think the next question is very, very much in line with the previous one. Annabelle asks basically, if I can summarize that, is it worth it in the environmental aspect? So is it really protecting the environment? What is the carbon footprint compared to traditional meat production?
So a lot of preliminary research has been done to explore what a life cycle analysis of cell-cultured meat could be compared to conventional animal agriculture. Different researchers come up with different explorations of while some types of meats may require a lot less water or a lot less energy. Some other studies have explored that if you don't have a more clean or sustainable energy source, this field may in the long run have more carbon and environmental impacts. So until we get to actual scale where we can do more proper testing to see what a proper facility would look like, it's up in the air right now. One of the leading companies in the field is a company in the US called Memphis Meats. And their CEO has previously stated that in both land and water use, cell-cultured meat could reduce that by 90%.
Great. Yeah. I mean, talking about scale, the next question is about scale. Can basically cell-based agriculture scale up to the level of conventional agriculture?
That's the million-dollar question. Look, right now we have lots of these different companies around the world looking to produce the whole process in-house, both their own cell lines, their own cell culture media, scaffolding, and even bioreactor technology. And the aim is, if you can address all these different technologies and scaling pain points, eventually the field can get to scale. In the UK, like I mentioned, so a few companies are looking specifically to address those pain points for everyone. So if they succeed, then this field is definitely scalable and can be a viable way to feed ourselves in the future.
Yeah, thank you. That was quite a hard question. So if I may, can I just ask two very open-ended questions to everybody? The first one is really a classic Innovation Forum question. Can you all see my screen? Okay. Yeah. So the first question is, do you have any advice for future entrepreneurs or current entrepreneurs, postdocs, students?
Get advice early on from sort of business advisors to advise you sort of around getting a business plan developed, and don't be afraid to fail, which might seem odd, but in the UK it's a bit of a stigma if people have companies, startups that go bump. In the States, it's seen as it's another medal on the chest. As long as you learn from your mistakes, that's the key bit. Don't go and repeat the same mistake again, because then you will be classified as a bit of a numpty. But I would say, don't be prepared to fail and work hard.
Thank you.
It's going to take a lot longer than you think, and more hours than you could possibly imagine. But go for it. If you've got a dream, go for it and take advice. Yeah.
Thanks. Alex, do you have any advice? We have matching background.
Gosh, I mean, I've been starting companies since straight out of university, and I think you either do it when you're very, very young and you're too foolish to understand how terrifying it is, or you do it when you're much older and you've got the experience. But seriously, in the vertical farming area, I think it's what I said. If I was starting as an entrepreneur in this business, I would be looking for those high value crops. I would be not following that sort of original plan of everyone does microgreens, and I mean no disrespect to people. I know there are people that are starting those sort of microgreen urban container farms all around the world, and there was absolutely its place for it. But if I was doing things, I would look for a really interesting high value crop. It might be something for the pharmacy industry, it might be something for the cosmetics industry, it might be a niche edible crop which has that high value, where you can start small but make a good return, and build from there. I think that would be my number one piece of advice for people starting in this field.
It's certainly a very, very important one. Jen, I saw you nodding excessively. Can you give us a few words, please?
I agree with Alex on the microgreens aspect. I mean, we've done very well from starting with microgreens, but we've realized that there's a limited market in microgreens. So it's about understanding your marketplace. That's the critical area. It's not about having a solution and trying to shoehorn it in. It's about understanding the marketplace and finding the solution that the marketplace needs, not a solution that you have that you think the marketplace wants. That's what I would say was the critical thing for a future entrepreneur. And also, follow your passions, be interested, do something you care about. I've built my career on an absolute love of plant science. I was, I think, 15 years old when I said I want to be a plant scientist. I'm now a lot older than that. So yeah, 21 years down the line, and I am living my dream. So do something you're interested in, because it will make you want to get up in the morning. It will make you want to work a 12, 14-hour day. You're going to be happy doing it. You don't care because you're doing something you're passionate about.
Yeah, thank you so much. I mean, talking about passion, Ahmed, you sound to me very, very passionate. Can you give us a few words as well?
Yeah, sure thing. I agree with what everyone has said beforehand. If you're looking into the agri-tech and food tech space, like all these talks I've mentioned, there's so many opportunities in so many different areas to go in and explore your own technical expertise or your scientific background or whatever your background is. All these future food and agri-tech technologies, as they come to scale, we're going to need people with all these different types of backgrounds and expertise. So if this field interests you, go for it. Don't wait for anyone to give you permission per se. Just jump and see where you land.
Yeah, thank you so much for the inspiration. So the next question is you've all again alluded during your talk is about the future of food tech. Ian, I think you're the most appropriate person to start up this conversation.
Right. Where do you see vertical farming in the next 5 years? It's going to increase in importance. I don't think it's going to be a total replacement for conventional agriculture out there, partly because, whilst the other speakers have talked about growing things like leafy greens, herbs, things like that, the UK grows an awful lot of wheat out there. To be able to grow wheat, it requires something like 30 times the light intensity that leafy green does, and it's very slow growing. The reason it's slow growing is it's adapted to grow outdoors in our weather conditions like that. So we need a different set of genetics, if you like. We need to modify or put in different genes to make it grow much faster, much smaller plant with more biomass that can be harvested and used rather than a root system to cope on that front. So there's a lot of genetics that are going to need to be adapted to cope with something like wheat that we grow an awful lot of out there, certainly around Cambridge, there's an awful lot of it. And the other bit is capital cost as well. To put in a vertical farm to grow wheat would be prohibitive in terms of cost. So I think there is a balance in terms of what could be grown. So there are other crops coming on. I think there's a new type of broccoli being developed out there currently, and as Alex sort of said, some of the nutraceuticals and pharmaceutical type crops are going to be key. So I think it's going to be a component of it, but it's not going to replace traditional agriculture in its entirety. And we always talk about one last thing. We always talk about crops. Nobody ever talks about animals. The Chinese have actually got 8-story vertical pig farms out there in China. They've also got a lot of African swine flu out there at the moment, suddenly ripping its way through the pig industry out there. But they have got capability to actually grow the plants vertically, the animals vertically, in what are in effect hermetically sealed environments like that to keep out viruses and other diseases. So they can actually grow them in quite sort of sanitary, hygienic conditions in comparison. So it's something to consider on that front. We could go vertical animal farming.
Yeah, well, that's
a different thought there. And one system more advanced than others. I'm not going to sort of say if one's better than any other. What I can say is we have funded companies looking at aeroponics, hydroponics and aquaponics like that within Innovate UK. We are technology agnostic like that. So we will fund anything that makes a lot of sense as long as it is going to be disruptive or innovative or have something new along that way, assuming they get through our assessors, that is. So yeah, we're keen to fund anything we can there on that particular front that is going to make an impact.
Thank you so much.
No problem.
So in the interest of time, Alex, can I ask you to say your opinion as well, please? Thank you.
For the next 5 years, I suppose I'd first of all go back to one of the points I made, which is if you're predicting the future, you're in dangerous territory. But I'd say I'd bear in mind for everyone that we are a very, very young industry. As I mentioned, you're only just now seeing some of the big venture capital moving in. But I'd remind everyone that about somewhere north of 70% of companies that receive venture capital funding fail, don't go anywhere. So I say a prediction would be that of all the businesses that are in the industry right now, a large number of them will not be in the business in 5 years' time. They just won't exist. Either they will just have failed or they've been bought by somebody else. And it's probably more likely than not, given we're such a young industry, that the big winner doesn't exist right now. It may well be one of the people on this listening to this webinar right now is going to be the chief exec of the big winner, the Amazon or the Google of vertical farming or of controlled environment farming in 5 years' time. So yeah, the future will not look like today would be a slightly asinine comment I would make.
Thank you. That's very interesting. Jen, can I ask you to say a few words about? Your talk was already to me very futuristic, but you can give us some advice as well.
Thanks for saying it's futuristic, but actually I'd say that if you guys look at the technology that Alex's company Liberty are putting out, it's actually all their technology is founded on the sort of the data that I was presenting. So the full visible spectrum LED lights, that's where the industry's going. We've gone from single LED bulbs, red and blue, all the way through, and we've made those realizations that chlorophyll isn't the end of the pigment to end all pigments. We need to sort of take into account other stuff. But yeah, for the next sort of 5 years, I'd say we're going to see a lot more companies entering the marketplace. As Alex said, we're going to see M&As. We're going to see people go bust. We're going to see stuff rise to the top. We're going to see some big players start to emerge. We're going to see more and more venture capital money coming in. It's a huge area for investment at the moment because of the combined annual growth rate of Agri-Tech and vertical farming. But I would say that people are going to start to differentiate themselves. It's not just going to be about, okay, everyone's doing microgreens, because that's kind of where we are at the moment. Everyone's doing microgreens because that's where you can make that's where you can make sort of the quick buck. And it's how you can sort of break even on your initial investment. We're going to start seeing people differentiating out. We're going to see people producing for pharmaceuticals. We're going to see people producing for cosmetics. We're going to see people adapting things to reduce food miles, like very specific working sort of areas. So looking at producing crops out of season so that we're not importing things from abroad. We're going to see more and more of these farms locating themselves in areas where, like, for example, at the moment, everybody's starting to work from home. I'm working from home right now. This is my study at home. I've even got a micro vertical farm in the loft, which I do some work in, which sounds crazy, but it's weirdly on the BBC News website if you have a look at that. So we're going to start seeing offices empty out. So we're going to start seeing vertical farms maybe repurposing those buildings. We're going to see these sort of large companies that hold a lot of the real estate looking to diversify out and looking to try and understand how they can use that. And that's where the kind of technology that we work in can start to sort of fill those voids. So I see a lot of change coming in the industry. It's not just going to be about sort of container farms. It's going to be about repurposing a lot of buildings that exist that need a new purpose because everyone's working from home.
Thank you. I mean, I'm quite envious because I've tried to make a vertical farming system at my place, but it didn't work out as well as I wished. So Ahmed, could you please say a few concluding words on this question for us?
Sure thing. So, like vertical farming, cell agriculture, and all these emerging food tech and agri technologies, think what we're really going to see for our future of food is a lot of choice for consumers and different options. That's going to be really exciting. We can have conventionally raised crops from fields, or some, the same ones from vertical farms that may be more urban. Similarly, with agriculture, we can have conventional meat, cell-based meat, and other alternative proteins like plant-based meats as well. So I think the future has to be a lot of choice for consumers when it comes to our food options, and that's pretty exciting for everyone.
Thank you so much. I mean, that's on this note. I just want to thank all of our speakers for agreeing to speak to us, and everybody who's attending, who's listening remotely, and everybody who will listen to our recording. We have another question about climate change, water scarcity, and pests and diseases. But I would like to invite everybody who's interested in climate to look at or perhaps attend our next event from Innovation Forum Cambridge, which is on the climate crisis and human health. So on that note, thank you everyone again for attending, and let's call it an end. Thank you.
Thank you, everyone.
Thanks very much.
Thank you.
Thank you.
Thank you.
Thank you.
Good night.